So, real quick, what's an ecosystem? Real quick, come on, put this thinking. It's only a half hour more. Yeah, yeah. It's a little bit broader than that, though. All right. I'm going to put this definition up. Then I realized I didn't really like it, so I have another definition. But it's pretty much a whole system formed by the interconnection and relationships of organisms with their environment habitat. All right, so I'm already bored. So I'm going to tell you how I kind of defined it. Anything is an ecosystem. It can be an ecosystem in an airplane. I won't go through all of that thing, but if somebody walks on that airplane and they're smelling a really bad, I'm not going to say body odor, we'll do perfume, and you are easily motion sick. So pretty much what happens is you end up being nauseous. Hopefully you're not going to embarrass yourself. But that's an ecosystem. It's the interconnectedness and the interrelationships of everything in the system. Now, I'm going to bring it down a little bit and in the function of an ecosystem and sustainability. So, an ecosystem, to keep it maintained, everything has to be working in its own little sphere, whether it be the whole Earth or the top of a pencil that has bacteria on it. However, everything in that ecosystem has to maintain to stay sustainable or keep it going. What would happen if all of our decomposers all of a sudden went off the planet? What was that? We'd have a lot of waste. So, I mean, that's a very basic, very, quick. Not all of our decomposers are going to go, but some of the main decomposers, if some bacteria that go and purify the wetland system and that purified water, if any one of those is no longer available by somebody pouring bleach down, what's going to happen if bleach is getting in there? All the bacteria die. We have that decomposed material is not going to decompose. So, all right. So onward and forward. So we have a couple of different ecosystems, broad ecosystems that I'm going to talk about today. And we have Carbuncle Pond, which is a freshwater ecosystem. We have the Atlantic Ocean, right off of Newport. And we have an estuary. None of these pictures have I taken. I have stolen them off the internet. I am just saying that now. So please do not distribute them widely. And basically within each of those ecosystems, there's a smaller ecosystem and specialized. We have, in the marine section, we have oceans, salt marshes, intertidal zones, the area between the high tide and low tide. And we have the coral reefs and freshwater. We have the lentic, which is slow-moving water. What would be an example of that slow-moving water? We said it earlier today. Would be ponds and lakes. All right, so we don't have any huge lakes in Rhode Island, but we have lots of ponds. And then we have the fast-moving water, the lotic zone, which is the streams and stuff. And then, as Heather had gone through, the wetlands. So all the organisms within this ecosystem are heavily dependent and have been adapted to those ecosystems. For example, trout, they like cold, well, of course I'm going to use trout. They like cold, fast-moving water. They rely on a lot of oxygen. Therefore, they don't do well in the shallower ponds. Bass, however, will actually live in warmer waters, and they actually make their nests right there in the shallows of these ponds and stuff. So multiple species can live by having different adaptations to different ecosystems. So I'm just going to try and go through this stuff really, really quick. Pretty much marine ecosystems, 71% of the Earth's surface is salt water. That's 71%. That means there's land masses and there's a lot about freshwater, but so 71% is salt water. And pretty much 97% of the Earth's surface Earth's water is salt water. So it leaves only about 3% out here for drinkable, potable water. The oceans are important. They do produce 32% of the world's primary production, and that's only in the zone where light can reach, which we'll talk about in a few minutes. It's important for nutrient recycling, for purifying water eventually, but for pretty much a lot of production and human recreation between boats, sailing, so on and so forth. The biggest problem right now, I would say, facing the marine ecosystem and messing with that balance of sustainability, that is pretty much, I would say, pollution and climate change. There's been a huge talks about climate change over the years, and the importance of what happens when those waters rise up from those glaciers that are melting. There's even, I've noticed in the past 15 years, especially 10 years since I've done this, that as the water warms up, the colder water species are moving up and aren't able to adapt. But we have these warmer water species that are able to come on up. We usually have it in Rhode Island, which is my favorite time to sing, is in the fall, because we have that Gulf Stream current that comes and pushes that warmer water up. But we're finding that southern species are getting closer and closer and are more pretty much prominent as the years are going on. So pretty much, really, what we're talking about is, as an ecosystem, there are certain functions that each of these systems have, their organisms that live there, have adapted to. For marine systems, especially, and I apologize, while I am a freshwater fisheries biologist, I study marine biology, so I kind of go out in tangents. But pretty much some of the factors they have to talk about are water, or characteristics that are important in marine in marine ecosystems is the water. Basically, water is a universal solvent, so it will dissolve everything. And about 85% of the minerals dissolved in are sodium and fluoride. That makes it that salty. And it's about 35 parts per million is what the oceans are. And parts per million, meaning that's the salt concentration. So all of these organisms that survive and live in our oceans, they have to be able to process that salt and deal with that salt because they need fresh water to still live. So they have different systems and physiologies that allow them to convert that salt water. Light. Light is a huge factor. What depends on light for survival? Sunlight. All of us. All right. Yeah, it was a trick question. So basically, the primary producers are our phytoplankton and our algae and stuff. The very basics of life start. So basically, light is really important. However, oceans are pretty deep, right? So light can only get into about 3,000, up to 3,000 feet. And that is, there's a euphotic zone, and that's the distance. Once you get to the end of that euphotic zone, some organisms can only survive. There's no growth and reproduction. So you only have the first 3,000 feet of an ocean that actually has production, substantial production. However, I say that, there has been evidence, obviously, there's heat vents, there's other specialized ecosystems within the ocean floor that do survive below 3,000, but we're talking those that depend on photosynthesis as well as organisms that need to eat those plant materials. The pressure is also deeper. They have to deal with that. Does anybody scuba here? Scuba dive? What's one of the biggest things that they tell you when it comes to pressure? Exactly. If you ever take a fish and and you bring them right up. If they're too far down, their swim bladders will actually come out of their mouths. That has happened in some cases. Also, oceans have big things are the dissolved gases. Oxygen, obviously, carbon dioxide. Carbon dioxide is used to produce oxygen for using sunlight through photosynthesis, and nitrogen. Reason why salt in saltwater environments, nitrogen is the limiting factor is because plants, in order for the algae to use those nitrogen molecules, they have to be fixed into nitrates. Don't ask me what fixes what or anything like that. Unless I look it up in a book, I won't be able to tell you. All I know is that in order for those macroalgae, in order to use those nitrogen molecules, they have to be fixed into nitrates. I know that's probably basic biology now, and I forget it. But then we have the temperature. Sunlight does absorb, but oceans are a lot deeper than 3 feet where that sunlight absorbs. So with wave action, if you notice, you walk into a pond outside your house, you're going to notice actual layers, and you can feel as you're walking in, it's definitely warmer on top and then gradually gets colder. Well, that doesn't really happen with the oceans as much because the wave action circulates. So it's about 30 feet that sunlight and those temperatures are circulating before it develops a thermocline. And then density. Saltwater is denser than freshwater. That's very important once we start talking about estuaries. And pretty much all the factors, they allow different zones for different, now I'm all worried. How bad are we? 10 or 12. Okay. All right, so ecosystem, marine ecosystem, freshwater ecosystems. So we have 0.8% of the Earth's surface is freshwater, where we could actually potable, drinkable water. But everything needs freshwater to survive. The big things I want to touch on in the freshwater ecosystems. Pretty much, that's you guys are going to be your big problem is irrigation, farm. In order for farmlands to go ahead, they need to be able to pull resources and water their farmland and water. And those multiple uses on 0.8% of the water of the Earth means that there is higher pollution risks as well as and it's all really dependent seasonally with fresh water. Whether we have enough snow. This year we're probably not going to have an issue because we have tons of snow out there, right? But as you look at the snow and while I'm saying, oh my God, I hope it doesn't snow again, I have to keep remembering, come August, we're going to be happy that it's snowing because that snowed this much. Because August is one of our drier months. That's when the turf farms down in South County need to pull out for irrigation. It's also when our rivers get warmer, less oxygen in the water.